Dear students in second secondary classes, hello everyone. Welcome to Math department of Sahmara High School. This presentation is the second session of chapter 17, permutations. Objectives of the second session are 1. To define a permutation of n objects taken p at a time. 2. To define a p-list. 3. To practice some applications concerning these two objectives. Let's start by definition. A permutation is an arrangement in a definite order of a number of objects, taken some at a time or all at a time. Of sure, order is very important. We will display some examples to understand well the difference between taking some objects at a time or taken all at a time. Example number 1. Given a word, rose. Then the word rose itself, another word, ROES and RESO, are some arrangements of the word rose. In this case, the letters are taken 4 at a time. Part 2. The words ROS, ORS, and ESO are some arrangements of the word rose, but in this case the letters are taken 3 at a time. Example number 2. Given the digits 1, 2, and 3, then the numbers 12, 21, 13, 31, 23, and 32 are all arrangements of the digits 1, 2, and 3. In this case, the numbers are taken 2 at a time. The definition of n factorial were learned in the first session. Make a quick review. N factorial is the product of the first n consecutive natural numbers. This is why n factorial will be n multiplied by n minus 1, multiplied and so on, by 3, by 2, by 1. Example 5 factorial is the product of the first 5 consecutive natural numbers. Then the value of 5 factorial equal 120. First main property. The number of permutations or arrangements without repetition of n objects taken p at a time, of sure p less than or equal to n. We arrange p objects out of n objects. This is why this condition is necessary. Is denoted by a p out of n and is equal to n factorial divided by n minus p factorial. The notation a p out of n is called arrangement of p objects chosen out of n objects. Direct example. Arrangement of 4 objects chosen out of 7 objects will be 7 factorial divided by 7 minus 4 factorial equal 7 factorial over 3 factorial. But 7 factorial is just 7 multiplied by 6 multiplied and so on until reaching 1. And the 3 factorial 3 multiplied by 2 by 1. Carry out 3 by 2 by 1 up and down to get the answer 840. You may use a calculator to perform directly a value of A4 out of 7. First application, arrangements of letters. Part 1. How many words of 3 different letters can be formed out of the 5 letters A, B, C, D, and E? Remark, the words B, B, B and A, D, D in this case are not the possible outcomes since the letters are repeated. Be careful. A word different means that the letters are not repeated. This is why these words are not the possible outcomes. Solution of part 1. Since repetition of letters is not allowed, then there is an arrangement of 3 letters chosen out of 5 letters that are A, B, C, D, and E. So the number of words is an arrangement of 3 out of 5 equal 60. Part 2. How many words of 2 different letters can be formed out of the word rose, and list all the words. Given the letters are different, this word means that repetition of letters is not allowed. Based on this fact, repetition of letters is not allowed, then there is an arrangement of 2 letters chosen out of 4 letters. For letters, due to a word rose has 4 letters. So the number of words is A2 out of 4 will be 4 multiplied by 3 equal 12. List all the words. Given a word rose, then the options are RO, RS, RE, OS, OE, SE. Now R and O can be permuted among themselves by 2 different ways, ROOR, RS, SR, RE, ER, OS, SO, OE, again permute the letters O and E to get another option, EO. Permute SE to get another option, ES. The total number of options in this case equal 12. Property. The number of permutations or arrangements without repetition of an object taken P at a time is equal to n power P. This property is called a P-list chosen out of an object. We will distinguish between this property and the previous property. In this property, take care. Repetition of objects is allowed. Application. Arrangement of letters with repetition. Part 1. How many words of 2 letters can be formed out of the word rose? With a condition, repetition of letters is allowed. Solution. Since repetition of letters is allowed, in this case, there is a 2 list chosen out of 4 letters R, O, S, and E. Then the total numbers of words will be n power P equal 5 squared equal 16. List all the words of 2 letters out of the word rose. All these options are mentioned in the previous application. And since repetition of letters in this case is allowed, then we have 4 additional options that are RR, OO, SS, and EE. The total number of options equals 16. New application arrangement of numbers. Given the digits from 1 to 6. Part 1. How many 3-digit numbers can be formed? In the below cases, A. Repetition of digits is not allowed. B. Repetition of digits is allowed. First of all, given repetition of digits is not allowed, then the numbers 112 and 555 are not allowed in this case, simply because in a number 112, 1 is repeated 2 times, while in the number 555, 5 is repeated 3 times. Now solution of A. Based on the fact repetition of numbers is not allowed, in this case there is an arrangement of 3 digits chosen out from a collection of 6 digits. So the possible outcomes is A, 3 out of 6 equal 120. Before I start by part B, repetition of digits is allowed. Important remark, then the possible outcomes 112 and 555 in this case are allowed. Start by solution of B. Based on the fact repetition of numbers is allowed. In this case, there is a 3 list chosen out of 6 digits. So the total possible outcomes is n power p equal to 116. Part 2. How many 3 even digit numbers can be formed if repetition is allowed? I will discuss some examples. 112 in this case is a possible outcome. 326, 556, and so on, 666. The units digits, as you notice on all these numbers, is even. The units digits of this number 2, for this number 6, and so on for this number 6, and repetition of letters of numbers is allowed. Start by solution. Let's start by solution. You may consider any 3 even different number is the form of 3 slots. In this case, I apply technique of slots. Start by a main condition. Since the number is even, then the third slot, which is the units digit, has 3 possibilities, is either 2 or 4 or 6. Now, since repetition of numbers is allowed, then the second slot and the first slot can be filled by 6 different ways. Then the possible outcomes of 3 even digit numbers is equal 6 multiplied by 6 by 3. 6 refers to the first slot. This 6 refers to the second slot, and the 3 refers to a main condition. This number must be even. Then the total possible outcome 108. Last application. Since we have covered arrangements of letters and numbers, let's try arrangement of people. In this application, we have 5 people and we have been provided by 3 chairs, and the chairs are in a straight line. In how many ways can the chairs be occupied? First method, use technique of slots. Let's take the 3 chairs as 3 slots and go slot by slot. Question here, in how many ways do you think the first chair can be occupied? Any one of these 5 persons can be seated on the first chair. This is why the first chair can be occupied by 5 different ways. And once this has happened, there is a remaining of 4 people, and this is why the second chair can be occupied by 4 ways. What about the third chair? Once the first chair and the second chairs are already occupied, there is a remaining of 3 people, and this is why the third chair can be occupied by 3 ways. Now 5 ways refers to the first chair, 4 ways refers to the second, and 3 ways refer to a third chair. To get the set of all possible outcomes, apply fundamental counting principle, multiply the ways, then the total possible outcomes equal to 60. Second method, since 3 people out of the 5 are to be seated on the 3 chairs, then any possible outcome is just an arrangement of 3 out of 5. In this case, we apply a rule of arrangement, then the total possible outcomes is equal to A3 out of 5. Then the total possible outcome equal to 60. We will display some options. For example, P1 can be seated on the first chair, P2 on the second, and P3 on the third. Another option, P1 on the first, P3 on the second, and P2 on the third chair. Final option, P5 on the first chair, P4 on the second, and P3 on the third chair. The total number of all these options is 60. Application. In a group of 10 people, $20, $10, and $5 price will be given. Question here, in how many ways can the prices be distributed so that each people take only one price? Before I start by solution, we will display some examples. First, name the 10 people as P1, P2, P3, and so on P10. One of the outcomes is $20 can be distributed for P1, $10 price for P2, $5 price for P3. Another outcome, $5 for P1, $10 for P2, and $20 for P3. As you see here, order is very important. There is a difference between these two possible outcomes. Let's display another outcomes. The 3 prices can be distributed as $20 for P8, $10 for P9, and $5 for P10. For example, another outcome, $5 for P8, $10 for P9, and $20 for P10. Solution. Since each people take only one price, it is a main condition, then any possible outcome is an arrangement of 3 out of 10. In this situation, we have just arrangement of 3 out of 10. Then the total possible outcome to distribute 3 prices on 10 people is equal to arrangement 3 out of 10, and the total possible outcomes or the total options are 720 ways. Short of a session. Order is important under this title to arrange P objects out of N objects. If repetition is not allowed, we apply this property, arrangement P out of N. If repetition is allowed, we apply a P list out of N. Listen to me. In each time to solve a question in counting, we must understand well if repetition of objects is allowed or repetition of object is not allowed, to decide which one of these two properties will be applied. At the end of the second session, I advise you to pause the video and try to solve the applications by your own. Now we are able to solve all exercises from 1 till 11 on your book. Thanks for your listening.